So a log of b gives us log a there is equal to c, and then so we can kind of swap them around here. So if we have that log base 3, we can put in a couple of points here, and let's do that straight away. So first of all, I'll move across to the side so we've got a little bit more room. And if we've got log base 3 of a 0, what does that mean? Well, looking at the previous equation there, we have 3 plus something, or 3 to the power of something, right, is equal to 0. Now that's not quite possible, is it? Right? So when we punch that into a calculator, we see that gives us the undefined. So we don't actually get the value of 0, but we do get that it tends towards like a really low number. So another example that we can use is log base 3 of 1. Okay, what does that equal to? That means that 3 to the power of something is equal to 1. All right, and the only way that can happen is if you get a 0, because anything to the power of 0 is equal to 1. So if you go like 4 to the power of 0, that's equal to 1. If you even put it in your calculator, x to the power of 0 is equal to 1, right? Just as a test. I know this is a non-calc question, but if you do that, it'll equal to 1. There we go. Another interesting point that can occur as well is that a log 3 all to the power of 3. What does that equal to? Well, in this case, it equals to if we put it in here, we say log to something is equal to 3. That means that it has to be to the power of 1. So this is equal to 1 there. So we have a couple of points that we can plot. We can plot point 1, 0, point 3, and 1. Okay, that should be good enough for this. And we know that the log kind of looks like this, right? That's what's going on. And we've identified 2 points here and here. Now it goes pretty close to like a negative value, but it doesn't quite get there, okay? And also we put it here. So let's go to our graph and put in the key points. Okay, so what we can do is put in our key points here. And so when we're 1 across, we're 0. And when we're 3 across, we're 1. And if you notice, it kind of looks a bit like the same thing, right? So I'll just plot that out a little bit better. Kind of looks like that, and almost mirroring something that comes through here. Okay, so just as long as you put those points in and make sure that they connect properly, then that will work very, very well. So that's the answer to part A. Part B just says, describe the relationship between them. Okay, and so what I said before is that it's really a reflection. All right, they're inverse functions. They're a reflection along the line y is equal to x. So what does that mean that they're an inverse function? Okay, let's go back down to here, and this can be our part B. So inverse means if I have a function, in this case I'm going to say f of x is equal to 3 to the power of x. What does the inverse of that function look like? Okay, so what we can do here is, this is exponential, so if you have plus and minus, they go together, times and divide go together. In this case, if you have something like x to the power of 2, right? So x to the power of 2, then we've got like the, like the square root and the powers. And in this case here, we're saying a number to the power of x. So we've got like the exponential, and so the exponential, and also the like a log or natural logarithm. So if we say y is equal to 3 to the power of x, I want the x to be here and the y to be over here, right? I want to isolate x. I want x on its own, so I want to solve for x. To do that, I can apply logs of base 3 to both sides, right? And I can use one of the rules to say that I can move that x down the bottom there. Let's draw that x a bit better. And what I'm left with is that 3 divided by 3. Now we did log₃, base 3, and the input is 3. Now in our previous example we did that and we said that that is equal to 1. So therefore we have solved for x. So we've replaced them, and that means that that's the inverse. So the inverse here, right, is equal to log base 3, all right, to the power of x. Okay, and they are the inverse of each other. Okay, and when that happens, when you find that inverse, it means that there is a reflection along the line y is equal to x. And that's what I pointed out earlier, right? We had that reflection along that dotted one, and that dotted one I'll just give a name in blue. That is equal to y is equal to x. So 1 mark, okay, to just say that it's the inverse and it's a reflection of 3 to the power of x across the line y is equal to x. So let's put that in words so we know what to write for the exam. And we say y is equal to log base 3 of x is the inverse of y is equal to 3x and is a reflection of y is equal to 3x about y is equal to x, about the line. There you go. That is the solution to part B. Now the next part, right, is asking for a proof. It's asking for the proof that ln AB is equal to ln A plus B. So what does ln of 2? What does that mean? That is like saying that is a log, right? Log E, right? The exponential, that 2.7 number, that's very special, base 2, okay? And so what that means is that e to the power of something is equal to 2. What is that something? That's what it's asking there. So what we're going to do is we're going to say, so we can say that a is equal to e to the power of x. Okay, and then b is equal to e to the power of y. All right. So if we have e x times by e to the y, okay, that is equal to e x plus y. That's the indices law, right? You can just like plus them if they've got the same base. Now let's take, right, that's our equation 1. Let's take the natural logarithm of both sides. Okay, and what that means is we can now use like a times by b, right? A times by b is equal to this one here. So it's like saying a times by b, right? But we haven't quite yet gotten it separated out into ln like a plus b yet. We haven't done that yet. So on our way. But that's the first bit. Then what we can say is that our value here, we can move that x plus y, right? We can use one of the indices laws, and we can move it down. So we can say using indices law, all right, and then we can just write an example of that indices law. We use a different value like z and w. That's equal to w ln z. So let's apply that. So what we can say now is that x plus y, right? X plus y are now all multiplied by e to the power of 1 there. And now this, right, this is just equal to 1. So we can say ln a plus b is equal to x plus y. Okay, and what that can give us is that if we go back to these equations here, right, we can say that ln a, right, is equal to x. Okay, so how did I get that? I can either just flip it around using our knowledge of how that works, or I can apply the ln e to the x here, bring out the x, and then cancel out that there. Okay, so that's what I'm going to write. I'm going to say ln of a is equal to x. ln of b is equal to y. So now sub, right? And then we finally get ln of a plus b is equal to ln of a plus ln of b. And that is where we leave it. That is the final solution there. Now I've got plenty more exam type questions, right? Plenty more exam type questions on the website. So you're more likely to face these kinds of questions in your exams and tests than some of the textbook questions you're likely doing right now. So do them to get better marks. And if you still need assistance, we offer tutoring online and in person. So reach out to us and we can see how we can help.